Dear students, let's discuss about isomerism. This one is the one of the most important topic of GOC, that means General Organic Chemistry. So let us discuss isomerism. What is isomerism? In class 10, all of you learned that isomerism means two or more compounds which two or more compounds which have same molecular formula, but different physical and chemical properties are known as isomerism. Okay, so what is isomerism? That means two or more compounds. How many compounds? Two or more compounds having or which have same molecular formula. Molecular formula will be same and different physical and chemical properties. Two compounds, molecular formula same, but physical and chemical properties will be different. These type of compounds are known as isomerism. So isomerism generally two types. Number one, that one is called structural isomerism. And second, that one is called stereoisomerism. So we will discuss about structural isomerism first, then stereoisomerism. Number one, that one is called structural isomerism. Chalo. What is structural isomerism? Structural isomerism means two or more compounds having same molecular formula but different structures, and also called physical, and obviously they have different physical and chemical properties. Okay, so these two types compound called structural isomerism. This structural isomerism also categorized by 6. What are these? By 6. Number A, that one is called chain isomers. Second, that one is called positional isomers. And third or C, that one is called functional functional isomer. Fourth, metamers. Metamers. Fifth, ring chain isomers. Ring chain isomers. And last, number 6, that one is called tautomerism. Tautomerism. Okay. First one, what? Chain isomerism. Second one is called positional isomers. Third one is called functional group isomers. Fourth, metamerism or metamers. Fifth, ring chain isomers. And sixth, that one is called tautomerism or tautomers. Let us discuss one by one. Number 1 is what? Chain isomerism with example. Chain isomerism or chain isomers. What is chain isomers? What is chain isomers? Chain isomers, all of you learned at class 10. Where? At class 10. What is chain isomer? What is chain isomer? Chain isomer means two or more compounds having two or more compounds having same molecular formula, but what is the change? Molecular formula same, but what is the change? The change is but different arrangement of carbon chain, different arrangement of carbon chain within the molecule, Okay. Let us discuss one example. What is this? So, if we take examples like C4H10, let us discuss about example C4H10. C4H10, that means it has 4 carbon atoms and 10 hydrogen atoms. Let's see what is the difference of structures or carbon arrangement. CH3, CH2, CH2, CH3. What is the name of this one? What is the name? Obviously, this one is butane. What is this? This one is butane. Name is butane. 1, 2, 3, 4, carbon number 4, and alkane. That's why butane. And CH3, CH3, CH3. This one is butane. This one 2-methyl propane. What is this? This one is 2-methyl propane. 2-methyl propane. So what is the difference? Let's see. Butane, this is straight chain, but in this compound, the compound name is 2-methyl propane. That means there is one branch. Let's see. Look at this one. There is one branch. Where is the branch? The branch in between the compound. Where is the compound? Within the compound or in between the compound. Where? In between the compound or within the compound or molecule. दैट मीन्स मॉलिक्यूल के बीच में जो ब्रांच होगा उसको ही कहते हैं चेन आइसोमेरिज्म और चेन आइसोमर. That means molecular formula same. In both the case, we have C4H10, 1, 2, 3, 4, carbon number 4, and hydrogen 3 plus 2, 5 plus 2, 7 plus 3, 10. Similar to 1, 2, 3, 3 is a 9 plus 1, 10. Okay, so both the compounds have or having C4 and H10. Molecular formula same, but structure is different. These two are also called chain isomers or chain isomerism. These two are called chain isomers or chain isomerism. Let us discuss about another examples about chain isomerism. Another examples. If we take like C5H12, C5H12. If we take another example like C5H12, let's see what is the structure. C5H12, CH3, CH2, 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 and CH3, CH3, and CH3, CH3. Look at this compound. Look at this compound. Look at this compound. What is the compound? C5H12. That means carbon number 5. Carbon number 1, 2, 3, 4, 4, 5. Carbon number 5. And number of hydrogens 12. This one is called carbon number 5 means pentane. Pentane. But look at this compound. What is this? This one is 2-methyl butane. 2-methyl butane. These two compounds also called chain isomers or chain isomerism. These two compounds also called chain isomers or chain isomerism. Why? Because different arrangement of carbon chain. Different arrangement of carbon chain. But molecular formula same. Next, we have positional isomers or position isomer. Positional isomers or position isomer. Number B. Number B means positional isomers or position isomers. Let us discuss about this. What is positional isomers? Having same molecular formula. This line is same for all. Having same molecular formula but different. What is the different? But different position of functional group or multiple bonds different position of functional group or multiple bond. The compounds having same molecular formula but different position of functional group or multiple bond. Let us discuss about one examples about this isomer. Okay. If we take the example C3H8O, C3H8O. If we take the example like C3H8O, let's see. C3H8O, that means CH3, CH2, CH2, carbon number 3, 1, 2, 3, hydrogen 8 is there. So this one. What is this? This compound is known as 1, 2, 3 propanol. What is this? This one is propanol. Propane 1-ol or propanol. This one is propanol. Propane 1-ol or propanol. And look at this one. Look at this one. What is this? This one is CH3CH3. 2 propan 2-ol. What is this? This one is propan 2-ol. What is the position? What is the position? 1, 2, 3. This one is what? 1, 2, 3. So look at the position of OH. Look at the position of OH. In first compound, the position of OH in carbon number 1. Where? In carbon number 1. But in second compound, the position of OH is in carbon number 2. This is the change in position. Different position. Different position of what? Functional group. We know that this one is what? Alcohol. This functional group is called alcohol. So different position of functional group. Okay, that's it. That is why these two compounds are called position isomers. Positional isomers or position isomers. Okay, so let us discuss about another examples like C4H8. Let us discuss about C4H8. Do you know what is this? Do you know what is this? C4H8. This one is what? Alkene. This one is what? Alkene. Obviously, C4H8, CN H2N general formula, CnH2n general formula. This one is alkene. CnH2n general formula. That means this one is alkene. Let's see. CH3, CH2, CH double bond CH2 and CH3, CH double bond CH bond CH3. Look at this two compound. At first compound, the double bond is in position where? The double bond is in position 1, 2. But in this compound 1, 2, 3. But in this compound the position of double bond is in position 2 and 3. But in this compound the double bond in position 1 and 2. So we can say that these two are what? These two are position isomers or positional isomers. Okay, let's move to next one. Let's see what is the next. We have another one is number C. That one is functional isomers. Position isomers and functional isomers similar but not exactly same. Little bit of same. Where is the same? They are also functional group. They are also functional group. But this one is the different. Where is the difference? Let's see. Having same molecular formula, but what is the difference? But different in functional group. Different in functional group. Different in functional group. In positional isomer, we learned that the functional group position of the functional group different, but in this isomer, look at here, but in this isomer the functional group, that means functional group like OH, like C double OH, like not C double OH, like OH, like C double bond O, like O bond O, alcohol, ketone and ether. These are the functional group. That position or the functional group different. In this compound, the functional group, in this isomer, the position of the isomer, position of the functional group is different. But here, same molecular formula but different functional group. Functional group will be different. Let's see one example. Let's see one example. What is the example? Like if we will take C3H6O, C3H6O, not C3, C2, C2H6O. So if we draw this one, CH3, CH2, OH and CH3, O bond CH3. So you can see that after seeing these two compound, you can able to tell that this functional group is what? Alcohol. This one is what? Alcohol. And this one is what? Ether. This one is ether. So in these two compounds, the functional group, molecular formula, the molecular formula C2H6O. That means in both the case, molecular formula is same, but functional group different. Different in functional group. That is why we can say that these two are functional isomers or functional group isomerism. These two are called functional isomers or functional group isomerism. Let's see another examples. Another examples like if we'll take another example like C3H6O, C3H6O. Another examples. Look at the structures. CH3, CH2, CHO, CH3, CH2, CHO, and this one is CH3, C double bond O, CH3, C double bond O, CH3. Where is the difference? Now tell, where is the difference? Difference is in this position. This one, only this, there is a difference. What is the difference? This one is called aldehyde. You know, this one is called aldehyde, but this one is ketone. But both the compound have molecular formula what? C3H6O. So we can say these two compounds are what? Functional isomers or functional isomerism. These two compounds we can say functional isomers or functional isomerism. Next, we have another number 4. What is the number 4? So we discussed about A, chain isomerism, B, position isomerism, and C, functional isomerism or isomers. And next, what is the next? Next one is called metamers. Number D, that one is called metamers or metamerism. What is metamers or metamerism? What is metamers or metamerism? having same molecular formula, having same molecular formula, but having same molecular formula, but what's the difference? But different number of carbon in either side of the functional group. So what's the difference? In metamers we have same molecular formula but different number of carbons in either side of functional group. That means in middle there's one functional group, either side means both side of the functional group there are different number. What? Different number of functional group. Let's see one example. If we take the example like C, not 3, C4. H, C4. If we take the example like C4, O, C4H8O. Let's see the example like C4H8O. C4H8O. So CH3, CH2, O, CH2, CH3. Look at this compound. How many carbons are there in this compound? Carbon number 1, 2, 3, 4, C4. Number of hydrogen 3 plus 2, 5, C4H10O. C4H10O. Number of hydrogen 10. Why? 3 plus 2, 5, 5 plus 5, 10. And look at this one. CH3, CH2, CH2, O, CH3. O, CH3. Now look. This one is ether functional group. So having same molecular formula, both the compound have same molecular formula, different in carbon number in either side of the functional group. So this one is ether functional group. There is carbon number 1, 2 in right side, in left side also carbon number 1, 2. How many? In both side the number of carbon atoms 2. But in this compound there is a 1 carbon atom, but in this side carbon atom 3. In this side carbon atom 3. So these type of compounds or molecules we can say that metamers or metamerism. These two compounds are called metamerism or metamers. Let us discuss another one examples like C5H10O. C5H10O. Another one examples. C5H10O. Another one examples. Look at here. C5H10O. CH3, CH2, C double bond O, bond CH2, CH3. CH2, CH3. And CH3, CH2, CH2, C double bond O, CH3. Look at both the compounds having Number of carbon 5. 1, 2, 3, 4, 5. This one also 1, 2, 3, 4, 5. Number of carbon 5 and number of hydrogen 10 in both the compounds and number of oxygen also 1, 1. Okay. So this functional group is known as ketone. This one also ketone. So in this compound, in first compound, the number of carbon atoms 2. The number of carbon atom in 2 in both sides. But in second compound, the number of carbon atoms 3 in left but 1 in right. So what is the name of this one? We can say the name of this one is what? Pent 3 on. Sorry. Pentan 3 on. What is this? Pentan 3 on. And what is this? This one is called pentan 2 on. So these two compounds we can say that metamers or metamerism. This is the difference. This is the difference only. What is the difference? The different number of carbon atom in either side of the functional group. Second last, not last, we have ring chain isomer. We have ring chain isomer. What is the ring chain isomer? What is the ring chain isomer? Ring chain isomer means we have same molecular formula, having same molecular formula but different number E. That one is called ring chain isomer. What is the difference? We have same molecular formula but having one cyclic compound, that one is called ring, and another will have chain compounds, that means aliphatic compounds. We have one cyclic compound, cyclo, and another we have chain compound like aliphatic compounds. So let's see examples. Examples I am telling. What is the examples? Like if we take C3H6, C3H6. Examples like C3H6, C3H6, C3H6. So we can write CH2, CH2, C3H6, cyclo. This one is what? Cyclopropane, cyclopropane, and CH3, CH double bond, CH2. Cyclopropane, and this one is what? Propene. This one is propene. Okay. So let's see these two compounds having same molecular formula, that is C3H6, but first compound contain one ring, that is why this one is called ring, and in second compound this is one chain, aliphatic chain, this one is chain. So we can say both the compounds ring chain isomers. We can say both the compounds are ring chain isomers. Okay, so you will do homework C6H12. This is your homework. All of you do this one. C6H12. C6H12. Do this homework. Okay. Last. We have last. That one is called tautomers. Tautomers or tautomerism. Tautomers or tautomerism. What is tautomerism or tautomers? Tautomerism means what? Two or more compounds. दोनों का क्या होगा? Same. Molecular formula same. But what is the difference? They state as dynamic equilibrium. What? Dynamic equilibrium. Dynamic equilibrium. They will stay as dynamic equilibrium. Let's see one example. What is the example of this one? This tautomerism we can say two types. Two types. What? One is dyad, and another one is triad. Triad and triad. Dyad and triad. What about dyad? Dyad means the position of the hydrogen atom will change in 1 and 2. Where the position of hydrogen atom will change in 1 and 2. Let's see. One, two. Look at here. In this compound, why this one is dyad? Why this one is dyad? Because the position of hydrogen, look at here. In this compound, the hydrogen is in position 2. In position 2. But here the hydrogen is position 1. Dyad. Change in 2. That's why these two compounds called dyad. Who can show dyad? Like cyanide, CN. They can show dyad. Like HCN. HNC. HCN and HNC. These are two dyads. Another, we have triad. What about triad? What about triad? Triad means the position of hydrogen atom change in 1 and 3. 1 and 3. 1 to 3. 1 and 3 and 1 to 3. Let's see. This one, number 1, number 2, number 3. This one, number 1, number 2, number 3. Look at here. The hydrogen atom from this carbon move to number 1. That means change in 1, 3. What is the change? Position change in 1, 3. Move to number 3, 1, 3. Here also, number 1, look at here, OH. But in this compound, there is O. And there is double single bond, but here double bond. This is double bond. And there is CH2, but here CH3. So position of hydrogen atom change to 1 and or between 1 and 3. This compound we can say, look at this. This one is what? C double bond O like. C double bond O like. That is why this form is called keto form. This form is called keto form. What is this? This one is keto form. But here we can see that this one is OH, alcohol, and here one double bond means this one is in. That means unsaturated hydrocarbon in. तो इसको हम लोग कहते हैं क्या? Enol form. So this one is keto form and this one is enol form. That is why this one also called, this one not and, here is one dynamic equilibrium sign. We should have to give here equilibrium sign. Why? Because they have state and dynamic equilibrium. This one is equilibrium and this form is called keto, this one is enol. That is why this tautomerism also called keto-enol tautomerism. Keto-enol tautomerism. Clear? This one is called keto-enol tautomerism. Out of this keto and enol, which one is stable? Out of this keto and enol, which one is stable? This keto is stable than enol. This keto is stable than enol. This keto form is stable than enol. This one is stable. Stable than enol. Keto form is always stable than enol. Clear? So we have completed the structural isomerism. These are 6 types. Number 1, chain, positional, functional group, metamers, ring chain isomers, and tautomerism. So students, we will discuss next stereoisomers in the next class. Thank you.